Did you know that glass bottles can be recycled into a porous rock called Supol? This innovative material is created by crushing glass bottles into fine particles and then heating them to create a foam-like structure. Supol is lightweight, has excellent insulating properties, and can be used in various applications such as landscaping, water filtration, and as a soil conditioner. It's a perfect example of turning waste into a valuable resource. Stay with us while we show you the entire process. Let's dive right in. First, it all starts with the collection of glass bottles. These bottles come from various sources such as homes, restaurants, and recycling bins. The glass is sorted by color, clear, green, and brown, as different colors can affect the final product. The sorted glass is then carefully cleaned to remove any contaminants like labels, caps, and other non-glass materials. This ensures that the recycled glass is pure and ready for the next stage. Once the glass is cleaned, it's crushed into small pieces called cullet. This cullet is then ground into fine particles, almost like sand. This fine glass powder is the primary raw material for making Supol. The size of these particles is crucial as it affects the quality of the final product. The finer the particles, the better the Supol will be. Now comes the most critical part of the process: heating. The fine glass powder is placed into a furnace and heated to a high temperature, around 800 to 900 degrees Celsius. At this temperature, the glass particles soften and start to expand, creating a foam-like structure. This expansion is what gives Supol its unique porous texture. After the heating process, the expanded glass is cooled down rapidly. This rapid cooling helps to solidify the porous structure, making it lightweight yet strong. The cooled Supol can then be cut or formed into different shapes and sizes depending on its intended use. Whether it's for landscaping, water filtration, or soil conditioning, Supol is versatile and ready to be put to work. Right here, you can see it is getting mixed into soil to act as a drainage mechanism. So, what makes Supol so special? First, it's incredibly lightweight, making it easy to transport and handle. Its porous structure gives it excellent insulating properties, which can be used in construction and horticulture. Additionally, Supol is highly effective in water filtration due to its ability to trap contaminants. And let's not forget, Supol is eco-friendly. By recycling glass into Supol, we're reducing waste, conserving natural resources, and creating a product that has multiple environmental benefits. As you can see here, Supol is used for planting trees, creating good drainage, and creating great soil conditions for healthy strawberries. From a simple glass bottle to a versatile, eco-friendly material, the journey of Supol is nothing short of amazing. The next time you recycle a glass bottle, remember, it could be transformed into something as innovative and useful as this. While we are on the topic of glass, let's go a bit further. What's more fascinating than witnessing how sand applied with heat can turn into beautiful glass pieces? We will take a look at how glass is made from sand. Of course, the first step of this process involves gathering the raw materials. In similar processes, the main ingredient is silica sand and other essential components like soda ash, limestones, and other additives. The sand needed is collected from this site. Before processing everything, a trained worker will check the appearance and condition of the sand. Then, it will be moved to the next step using conveyor belts. The sand will be funneled through these machines onto the next. Although sand particles are relatively smaller, they are still prone to having impurities and unwanted debris. To remove these, the collected silica sand is washed with water. Since we are looking at the process inside a large facility, they use these huge machines with water sprays to make the whole step efficient and easier. The use of water helps in removing large debris, clay particles, and organic matter from the sand. In some facilities, they even go to another level by using other techniques like agitators, screens, and gravity-settling tanks. Regardless of what method is used, removing the impurities is the goal of this step. For the most part of this process, machines and technology are already used. This facility has several systems and connections that make the flow of things smoother. In fact, these machines also have different monitoring tools and screens to help ensure a consistent movement and process. Despite these technological advancements, the workers in this facility still manually start them. They also need to monitor everything physically to make sure that nothing goes wrong. These machines are the same ones that help the sand move to the next step. After a while, the sand will already be clean and prepared. However, since they used water, it will be moist or wet. This is not the proper or optimal state of the sand you would want. There's just so much water in the sand. To fix this, the processing facility allows the washed sand to go through a screw classifier. This is a special machine made for glass manufacturing, and it helps separate the sand from the water after the initial washing process. You can somehow see how it works just by looking at it, but let us explain to you its mechanism properly. First off, the sand slurry, or the sand mixed with water from the initial washing step, enters the machine. From the top part, which is the washing area of the sand, the slurry goes down to the bottom of the screw classifier. After that, this large rotating screw will move the slurry upwards along an inclined trough. During this whole upward movement, the water and lighter impurities are forced to flow over the edge of the trough due to gravity. Meanwhile, since the sand is heavier, it will be left in the screw and carried upwards. There will be a lot of water and sometimes even small impurities that will come out of this step. So, it is important that this machine is built with a mechanism that helps these water and impurities exit. The screw classifier is connected to different outlets responsible for waste management. For the most part, the machine does all the work in this process, but workers still need to monitor the whole thing to make sure that there are no blocks or mishaps. The concentrated sand particles reach the top of the trough and are discharged into a separate container. Speaking of concentrated sand particles, they will be pushed over to the edge of the machine. It is very fascinating how a wet slurry like this can turn into fine sand. The excess water will be channeled to a different outlet, so it does not get in the way of the clean sand. On the other hand, the sand will be moved upwards via a conveyor belt. This is in preparation for stockpiling them as they wait for the next step. Although it may seem like there will be a lot of wastewater during this process, do not worry because everything is accounted for. This facility has already built its own mechanism of making sure that it does not disrupt the environment, but at the same time still get the job done. Of course, the process does not just stop there. As you can see, there is still a lot of water and some impurities left even after the initial washing. So the sand will go through another wave of washing again. This is to ensure that only the sand and no other debris is mixed up, but this time the sand will be exposed to water after it has been through a screw classifier. Most of the facilities do this for a number of reasons. One of them is to remove all the debris, clay, and organic matter. If they are using heavily contaminated sand, it is necessary to wash it twice to remove all the unwanted debris completely. They might also do this to reach the desired purity level. There are different levels of glass sensitivity, and some of them require extremely pure and double-washed sand. While additional washes increase purity, they also add time and cost. Facilities strive for a balance, sometimes using a two-stage process if it offers the best combination of purity and efficiency for their specific needs. Through the help of these channels for water, the sand will be washed, and unwanted debris is removed without wasting too much sand. This washing process is essential to ensure the quality and clarity of the glass produced. Interestingly, the purity of the sand used directly impacts the transparency and color of the final glass product. For instance, high-quality white silica sand is often preferred for producing clear glass, while sands with iron oxide impurities may result in green-tinted glass. This attention to detail underscores the precision required in glass manufacturing and highlights the importance of sourcing the right materials for producing different types of glass. As you can see, even with the initial washing, there are still a lot of impurities and debris left. This is why an effective and efficient second washing is needed. Just like what happened during the initial washing, the sand needs to be drained out of water. This will ensure that the facility only processes the sand in its optimum state. This is done through the help of another screw classifier. It basically does the same thing as the previous one. But in this step, the workers need to make sure that all water and unwanted debris are removed, since this will be in preparation with the glass manufacturing. After that, the sorted out sand will be stored using the stockpiling method. Then they will just lie and wait for the next step. Eventually, the processed sand will be transferred to the glass manufacturing facility. It is important to know that in some facilities, they also use recycled glass to form another glass product. Regardless of what the material may be, these will go through melting. The prepared mixture called the batch, is loaded into a furnace and heated to extremely high temperatures, around 1500 degrees Celsius. This intense heat melts all the ingredients, transforming them into a molten glass liquid. The molten glass is then shaped into its final form depending on the desired product. There are different forms of glass depending on what the facility makes. Then, the formed glass is cooled down rapidly but not too quickly through the controlled cooling process, called annealing. This process relieves internal stresses that could cause the glass to crack. Then, they are finished and prepared for market distribution. So let's move on to the manufacturing process of making glass bottles and filling. Once the raw materials have been gathered from the previous steps, they will be grinded into even smaller pieces to make the process easier. Then they are mixed together in batches and sent through large furnaces called melters, where they undergo extreme heat upwards of 2700 degrees Fahrenheit. This process transforms the mixture into molten glass that can then be formed into desired shapes. At this high temperature, the sand melts, losing its crystalline structure and forming a viscous liquid called molten glass. Gases and impurities are removed during melting to ensure the clarity of the final glass. When the glass is already formed, they are fed through this machine that checks its quality. Then, they go through this series of refiners to make sure that the surface of the glass is smooth and even. After that, they will be lifted by this machine to prepare the transportation to the bottle manufacturing facility. Once they reach the facility, they will be checked. Then, the glass will be melted and formed into these cylindrical structures. This molten glass is now called a gob. This facility uses the method of machine pressing in making their bottles. This is a process with a combination of heat and mechanical help. The gob falls into a preheated mold with two parts, a neck mold and a body mold. A metal plunger descends forcefully onto the gob, pressing it down into the mold cavity. This pressing stage shapes the neck and initial body of the bottle, including details like threads and embossing. The newly created bottle should be cooled rapidly after shaping, reducing their temperature by hundreds of degrees within seconds. Once cooled, quality control measures inspect each individual bottle for defects such as cracks, deformities, or weak spots. Non-conforming pieces may get recycled back into the production cycle. This method of making bottles is preferred by factories because it helps them produce more and be more efficient in their operations compared to the traditional methods. Plus, this technique also offers good control over the neck and body shapes, creating consistent bottle dimensions. Now that they have the glass bottles, you may be wondering what the next step would be. Of course, the next steps will be about filling them up and preparing them for wider market distribution. This part of the process is just as fascinating as the previous ones. You will also see in the next parts of the video how this facility has successfully incorporated machines and technology in their whole process. Without further delay, let's get started on the process of filling up the bottle. And it all starts with the bottle preparation. Empty bottles are delivered to the factory and unloaded onto conveyor belts. They pass through an inspection station using cameras and sensors to detect cracks, chips, or other imperfections. After that, bottles are then washed and sterilized, usually with a combination of water, sanitizer, and sometimes hot air or ultraviolet light. This all depends on the facility you are looking at. Filled bottles are transferred to the filling line, where they are automatically positioned and held in place. Filling nozzles descend onto the bottle openings, each designed for specific bottlenecks and flow rates. Most of the time, the factories use the method called gravity filling. This is where they just feed the bottles on the machines, and the liquid just flows freely under gravity through the nozzles present. In very advanced factories like this one, they are now able to use sensors to monitor the liquid level in each bottle. Even without the intervention of workers, it will just stop filling when a specific level is reached. Filled bottles move to the capping station, where a capping head automatically screws on the caps with precise torque. This part of the machine is also equipped with leak detection systems that make sure they are properly sealed. Batches upon batches of bottles are capped in this facility every day. There are different kinds of bottle caps. It can be screw-top caps that are made of metal and have a threaded design that screws onto the mouth of the bottle. These are also the most commonly used closures for glass bottles. There's also the crown caps. These are similar to screw-top caps, but they have a more rounded shape and a smaller diameter. Crown caps are typically used for smaller bottles and are popular in the cosmetics industry. After capping, the bottles then proceed to the labeling station, where self-adhesive labels are applied using pressure rollers or tamp applicators. Depending on the product, further labeling or coding might occur, such as adding expiration dates or batch numbers. The number of bottles that can be filled per day in bottling plants varies depending on several factors, including the size of the bottling line, the efficiency of the production process, and the type of beverage being bottled. However, large-scale bottling plants can fill an impressive number of bottles per day. For example, some modern bottling plants can fill anywhere from tens of thousands to over 1 million bottles per day, depending on their capacity and the demand for the product. This staggering output showcases the high level of automation and efficiency in modern bottling operations, where advanced machinery and production techniques enable rapid and consistent production. Bottles undergo final inspections using cameras and sensors to check for leaks, proper labeling, and overall quality. Rejected bottles are removed from the line, while the accepted bottles are grouped and packed into crates, boxes, or onto pallets for distribution. These bottles are moved via conveyor belts and are prepared to be sealed. All of the steps in this process, from the preparation of the boxes to the actual sealing, is done by machines. These bottles just have to move along these conveyor belts, and they will be wrapped in plastic, put in boxes, sealed, and prepared for wider distribution. Since we are dealing with glass bottles, it is important that they are secured during the transportation. So they are put in these large crates by group. Just like the previous parts of the process, this step is completely mechanical and automated too. This robotic arm stacks the batches of glass bottles on top of each other. After that, it covers the whole thing with a protective plastic so that they do not fall down or get damaged. And there you have it. From molten sand to sparkling bottles, we've journeyed through the fascinating world of glass bottle manufacturing. It's a complex process, but the result is a versatile and sustainable packaging solution that touches our lives in countless ways. The next time you reach for a refreshing beverage or a jar of your favorite sauce, remember the incredible journey that bottle took, from fiery furnaces to precise machines. This has been Lord Gizmo, and we hope you learned a thing or two. Before you leave, please don't forget to show this video some love by giving it a thumbs up, subscribing to our channel, and clicking the notification bell so you can get notified whenever we have new uploads. You can also tell us in the comment section what videos you want us to feature next. Thank you for watching, and see you in the next video.